This is TWiT.
So I just wanted to talk about the, I've been spending a lot of time with this open source and open hardware project lately called RGB to HDMI. So most people know, if you don't know by now, I've been interested in vintage computers for a while, but lately I've really been getting back to my roots, so much so that I started a YouTube channel called Retro Hack Shack, where I work on these systems, bring them back to life, fix them, clean them, whatever they need. And one of the projects that I've been doing, I did 4 episodes now about this, is called RGB to HDMI. So one of the issues with older systems is that they, you have the video output, the video technology at that time was either composite. A lot of times it was RF modulators that you had to use to connect it to a TV, right? And the quality of the video is pretty poor. And over time, capacitors degrade. The output can get even worse over time. And so a lot of times, like people will add composite mods or RGB mods to systems. Well, this particular project has taken a Raspberry Pi Zero and then built an additional daughter board, I guess called a hat. If people are still, that's what Raspberry Pi was calling them. I don't know if people are still referring to them that way. But they added on, let me grab one. Actually, I've got one right here. A little visual demonstration. So this is a Raspberry Pi and a little daughter board on top, right? And what this allows you to do is it connects to your, YUV or RGB output of your old system and then converts it through the Raspberry Pi to HDMI. So now you can connect an HDMI display up to your old system and get, I don't know how high. I know it goes at least to 1080p quality. And it's pixel perfect. And there's a lot of other cool additional things you can do with it as well. For example, the PAL version of the Coco, right? So the Tandy or Radio Shack color computer, the PAL version of that was never able to take advantage of the NTSC artifacting, which is a way of shifting colors. The Apple II did this as well. The way of shifting colors in the signal to give you colors where there weren't any before, right? So it was kind of a hacky way of getting colors on those systems. Well, the PAL version could never take advantage of that because they weren't running NTSC. They were running PAL, so it never looked right. But because it's going through the Raspberry Pi in the setup, when you hook up one of these, you can emulate those NTSC artifacts even in the PAL version. So not only do you get HDMI output, but you get, at least in Europe, you get access to these NTSC color artifacting that you weren't able to get before. So just really a really cool project. Like I said, the project is open source. The hardware is open hardware. I built up my boards myself. And the developers, again, because it's open source, they're getting immediate feedback. And so I've been working with some of the developers for building out, for example, the color computer support I mentioned. We just go back and forth. I think we got that worked out in less than a week, and all of a sudden we have a new system that this board can support. So I think it supports like about 20 different old systems right now. And I just wanted to bring it up as a great example of open source, open hardware project that is really benefiting the community, especially this community, the retro system community, in being able to bring these old systems either back to life or improve them in a way that makes them much more usable with the current technology today.
Now, with RGB support, does that mean that even things like old consoles that have a SCART output can get plugged into this thing? So that you can take,
Yes.
say, a Super Nintendo through SCART to your Raspberry Pi and then up to your big screen?
So so it gets a little complicated. Once you get to the past the original NES level, then the speed or the speed of the signals, the frequency of the signals gets so fast that it's difficult for this board to be able to pick them up. Because what this does is it compares voltage levels, right? So it's sitting there monitoring the voltage levels of all these signals. And when you get to Super Nintendo and Sega Genesis, some of those systems, the speed is so fast, it just can't detect the voltage changes in between the cycles. So so you get to a certain point and you're not able to use it anymore. You'll have to switch to something with an FPGA on it. This runs off a CPLD. So sorry, we're getting in the acronym weeds there for those that aren't into this, but you can think of if you've heard of FPGA boards that do all the emulation, really super fast systems that can emulate some of those older technologies. CPLD is like one step below that, but it's also relatively cheap. So I think I built up my board for I want to say less than $30 all in, including ordering the PCBs, ordering all the parts, and I use it on a ton of systems now. My old IBM stuff that has CGA and EGA output, I use it for. Like I said, I've used it for the color computer. It supports, BBC Micro, and there's even mods you can get so that it'll support Amiga and Commodore 64. Those take a little bit more work, but I've just been really impressed by this project, and I keep going back to the fact that this type of project would not be doable if it wasn't open source and open hardware. Because even if you put something like this on let's say you created it and then you wanted to get it out in the world, the iteration just would not be possible like it is since it's open source and open hardware. So really impressed by this, and kudos to the developers that are working on this behind the scenes. They're doing a great job.